Hello, it's Friday and you know what time it is. It's time for a new podcast from Sofeast, the China Manufacturing Decoded podcast. It's episode 164. Renaud is with me. I'm Adrian from the Sofeast team as well. Hi, Renaud.
Hey, Adrian, and hi to all the listeners.
Yeah, hello to everybody tuning in from all around the world. And actually, we do get a lot of people listening from all over the place. Renaud, if you've seen the stats recently, I mean, we've got people in Africa, we got people in South America, of course, the US and Canada and Europe. It's pretty crazy. We got a global reach here, and it's nice to see our little community growing as we go along with this.
Yeah, that's great.
So, one of the things that we have discussed in the past, and this is today's topic, is environmental concerns and how this is affecting people doing manufacturing, people bringing new products to the market. And today we're going to be talking about how to design a product for lower environmental impact. Basically, we're going to be looking at some environmental improvement strategies for our product.
It has to be baked from the ground up. That's a difference from what we discussed before when we were saying, okay, people come up with some kind of conceptual design, then they work with an industrial designer, they get an industrial design, but still there's always some, certain things that are going to be very specific, maybe to some of the processes, the manufacturing processes involved in making some of the parts. And maybe they, I don't know, if they want to do the assembly in a high labor cost country, then maybe they need fewer parts and really think through the assembly about how to make it really easy. So it, the same product can be made in 20 seconds rather than 3 minutes, and there's some real cases like that. Here, we're not talking about sort of catching the design at one point where it's already relatively advanced and then thinking of, okay, how to get that into manufacturing or how to tweak it to get something better, right? Basically, if you want the product to be more environmentally friendly, and if it's really a major part of the strategy, well, it's got to be baked in the design from the start. And we're going to see more and more of that. There's a lot of products in the market now that sort of greenwash, right? They say, something kind of meaningless, like, the cardboard of the packaging, is recycled or something. Okay, yeah, but the entire product, is like is 98% of the environmental impact, right, of the whole product. I mean, this and it comes from China, and you send it by plane because it's late and everything, and you still you're still there to say it's green, So there's going to be there has been some pushback against this type of greenwashing. And like always on this kind of topic is the European Commission that's working hard on this. And they announced that they would make some amendments to the directive about, what is it, false claims. I forget the exact name of the directive, false claims, something else directive. Okay. And if you pretend that your product is environmentally friendly, if you show some kind of green leaf or something like that lets people think that it's environmentally friendly, if you cannot back it up by, some specific performance testing and checking maybe the energy consumption, for example, or durability, reliability testing or something like that, or if you can really bring material evidence, then it's actually against the law. Okay, soon, right? We're talking 1-2 years later, but I would expect something roughly similar in places like Canada, Australia, right? UK might follow that in one way or another, right? USA, well, we never know. They have their own agenda. They're very big and they have a different general attitude to regulating businesses. So this is going to be more and more important, right? Especially as also governments try to regulate, but not necessarily in imposing certain rules to businesses, like you must do this, you must not use this or that, right? I mean, there's some of that, of course. For example, this is going to come in the European Union again, first, 2025, the digital product passport. And we discussed this before and we wrote about it. It's part of the proposal for the ecodesign for sustainable products regulation. Okay, it's going to be a regulation. Like as soon as it comes into play, boom, it's going to be exactly the same requirements in all the countries of the EU. Pretty serious. So that product passport's main objective is to provide the consumers, the buyers, the shoppers, whether it's in a shop or in e-commerce, right, on a website, provide them with the information about the product. So, more and more information will have to be provided there so that they can actually make the right decisions and maybe, put a bit of pressure on the manufacturers that way. Okay. Sort of stimulate competition in a right way rather than just vote some regulations from on high, right? So that's the context, right? There's going to be some regulations pushing the manufacturers. There's going to be some transparency to consumers and more pressure from consumers and users and whatever, right? B2B, B2C. That's a trend. That's a mega trend. There's no way to ignore it, right? So more and more businesses are thinking, hey, let's try to design products so that they are less environmentally impactful, right? And then some of them, I'm not sure we discussed it before, but we wrote about that. So some of them even try to design products that not only have less of a bad impact, but are really going into a circular economy, okay? And that's when you hear about cradle to cradle, right? Like the cradle where like the product is born and then the product goes end of life, but actually is reused or recycled, but like not downcycled, but recycled or reused in a way that is as useful without consuming a lot of energy, without the addition of a lot of chemicals and whatever, other substances. So when you reach that state, then the product is kind of, nearly circular and sustainable. Okay, sustainability is not just less, a lower bad impact on the environment. It's also allowing people to stop just like making stuff and transporting stuff and depleting natural resources of the planet, right? So that means the product can just keep being reused and reused and reused and keep providing value with minimal energy and consumption of resources, etc., to keep recycling it, right? But that's sort of the ideal, right? For most companies, the logical next step is try to think, okay, how can we reduce the impact on the environment? Like how to do less harm, how to be less bad. Okay, so that's sort of the general context, right? And that has to be taken into account at the design stage, the early product design stage, right? Otherwise, like it's way too late. When you have a product already designed, well, I mean, 90% or maybe more of its environmental impact is already decided. Okay, well, and then, okay, you still have a little bit of room. Okay, maybe manufacture it in places that maybe, retreat the water and have more energy efficient machinery and so on and so forth, and maybe very close to the market. You can still have an impact, of course, but at least 75% of the environmental impact is already set, and in some cases much more than that, right?
Yeah, because if you've locked in like all of your components, for example, then into the design, into your BOM, and these maybe are not very sustainable materials or components. If you're going to then say, oh, we need to get rid of these and we need to find completely sustainable options, basically you're scrapping the whole product. You're starting from scratch.
Yeah, right. Well, that's a good point. So what we want to talk through basically in this podcast is some good practices for designers, right? For product designers who want to design and develop and bring to market some more environmentally conscious or more environmentally friendly products, or let's say products that do less harm, right? And this comes from that IEC standard. So IEC is the, what is it? International Electrotechnical Commission, right?
That's right.
IEC, yeah. Okay, so IEC, they produce standards, among other things. They only think about electrical electronic products, okay? Whereas the ISO that, most people at least have heard of, like ISO 9001 and these kind of things, is much more transversal, touches on a lot of different topics, about a little bit about everything, right? And in some cases, there's some standards that are sort of co-produced and co-distributed by both ISO and IEC, right? ISO/IEC, maybe 27001, for example, for information security measurement system, right? Okay, so it's kind of a bit like ISO, but usually more technical, more into the technical aspects, and really about electronic products. But really, what we're going to talk about applies to a lot more than electronic products, right? So they have this standard IEC 62430, right? 62430, published in 2019. That's called Environmentally Conscious Design, Principles, Requirements, and Guidance. Okay, so there's a lot of principles and guidance really to help. And then if you say, well, we really we comply to ISO 62430, or you require your design house to comply, then there's requirements. Okay, they can only say that they comply to this standard if they really comply to all these requirements. So it's also written in that way. Okay, so I'm not going to bore you with all that stuff about that standard, but they have a list of really good suggestions, right? In one of the appendices, and that's what I wanted to cover. It's cut in five big categories. One is design for material sourcing. Then it's design for manufacture. Then it's design for transport and distribution. Then it's design for use, including installation, maintenance, etc. And finally is design for end of life. So here you see a pattern that's very common when you start to look at the environmental impact of a product or a factory or something like that, is that they look at the product life cycle, right? The product life cycle, again, cradle to grave, right? Typically. So the product is designed, the product is made, the product is distributed, transported, then it's in the hands of users. They use it, they store it, they use it, whatever, right? They repair it, they change some parts and so on. Then they get it no longer works, or maybe it really outlived its usefulness and they stop using it. Okay, then what do they do with it? Do they just throw it in the landfill? Can they do something useful, right? So that's the structure, and that's always a very good structure for thinking about the environmental impact of a product or manufacturing process or anything. Okay, so let's go through these five big families of considerations.
Yeah, that makes sense. That's good. So the first one then is design for material sourcing. Right.
So as a designer, you have to pick what materials, right? And at the same time, how they're going to be made. Okay. So I'm going to read through the options that they suggest and provide some comments. But it's usually I find it quite, very good guidance. Okay. So they start with consider reducing weight and volume of product. Well, yeah. That's going to have an impact, obviously, on transportation, etc., which, of course, consumes, have several types of impacts, right? Consume gas or kerosene or whatever, and also emits greenhouse gas types of gases, right? So reduce the weight, reduce the volume. That also typically means less packaging if it's less volume. And also, if it's less weight, well, very often it also means less consumption of material. Okay, so that's a good one. Another one is increased reuse of products via remanufacturing. There's so many examples of this, right? I don't know, like years ago, actually it was my first job. I was working in a factory making cork for wine, okay? And there's so much waste because when they want the nice cork for the nice bottles of wine, you only pick like the most sort of pure and noble parts of the bark of the tree, right? And then you have maybe half of the cork is sort of wasted. Okay, so what do? They will also take all this stuff, purify it, wash it, and so on, grind it down, right, in like small sort of pellets, if you want, and then they would have some kind of binder. Okay, it's not really glue. There's a sort of glue that binds it together. They mold it, and poof, you have a cork. And actually, I believe by now, most cork sold in the world, when they are in natural cork, maybe it's half of them, maybe it's more than half, but a lot of them have this, sort of are reconstituted cork, molded from small granules, right? So that's an example.
I think another one and I know that sneaker brands are probably not the most sustainable companies, but
right.
I think Adidas claims that they have this range of shoes which are I think they call it made to be remade, and they're made from all parts that can be taken back by the company and then basically sort of machined and used in making new products.
Yeah, they're pretty cool. Right. So if, of course, it might not be as durable, as nice, as whatever, right? But if you communicate that and you make it a marketing, like a selling point, actually some customers will go with it, right? It's sort of a bragging right for them. It's like, hey, look at these shoes, you won't believe, that sometimes make a lot of sense. The next one is increased use of recycled materials to replace virgin materials. Well, it's kind of what I mentioned before. So, so for example, plastic injection molding, there's a lot of companies really insist. They say, oh, this product you have to use only virgin material, right? Otherwise it's going to be cracking, it's going to be, it doesn't have the same physical properties and so on and so forth. Like, okay, so Chinese suppliers like, oh, okay. But sometimes they put 10% or 20% back into it, right? And they kind of, sometimes they're a bit nasty. They try to find the limit, at 35%, it seems like, really, it cracks easily. Maybe we should not go higher than that, right? But what they're doing actually is a form of optimizing for that. And sometimes, you have 20% of regrinded material. Well, the cost is lower, and overall the product is just as good. There's no discernible difference in some cases, right? So you do it in a scientific way, you test, and sometimes you can really go with that. After that is increase the reuse of components and sub-assemblies. Well, reuse as much as you can, right? Is sort of the same. It's not just materials.
Our old friend Apple that we've mentioned a number of times, I guess they're kind of a benchmark in many ways. I saw recently, Renaud, there was a really cool video actually of they've got like this special robot. It's got a name. I don't remember what its name is. It's like a human name. Right. And it's sort of like picking up old iPads that have been sent in. And if you've bought an Apple product, you can send them your old one and they give you some money off whatever you're buying and things like that. And they say that they recycle it well. they appear to actually do that. So the robot sort of rips it apart and then picks out all of the little components and those can then be sort of reused. So I think that's an example.
Yeah, Daisy. Yeah. In this case, it's more like reuse of materials. The copper, the gold, the whatever. For sure, and more with batteries. The lithium, the cobalt, and so on. So. Yeah, they try to extract maybe by heating it up and melting it or some other ways. Right? They have a number of ways to do it depending on the application. Yeah. Next one is reduce the use of scarce materials. Okay, yeah. So, for example, Tesla, they've been working very hard with their batteries to reduce the amount of lithium and cobalt and some of the materials that they know they have the most trouble sourcing, right? So they've been pushing their engineers to work very hard in that direction. That's an example. Next one is minimize or eliminate the use of substances hazardous to health or the environment. Well, yeah, the most common example probably is lead, right? The metal that's very easy to work with and so on and so forth. But lead, I mean, if you people say that Rome got into big trouble because all the pipes were made, with lead, and people just got nuts, right? It really got to the brain. But also, yeah, in some ways, it's bad for the environment, right? So there's a lot of examples of that. Next one, decrease the need for consumables. Yeah. So, I mean, look at internal combustion engine cars, right? Over the years, for a car, let's say that's 1.2 tons, metric tons. That's traveling at whatever 100 kilometers an hour or 60 miles an hour. Well, you compare the gas guzzlers of the 60s to the usually very efficient engines of today, and you see that you have better performance, faster acceleration, much less noise, and so on. But also, it consumes way less gas, right? So that's an example. But here, let me see. Yeah, here it's more like for producing the materials that they're talking about. So, need for consumables, and what goes together with the next one actually. Yeah, decrease the quantity of energy, for example, energy and oil used throughout the product's life cycle. So if you make a car, that consumes less, that's better. But also, for example, if you use steel rather than aluminum, well, I think I read somewhere, if to make aluminum, the manufacturing processes have to consume something like 6 times more energy than steel, right? So big difference in impact here. That's an example.
Yeah.
What else? Next one is specify materials that emit low or zero volatile organic compounds, VOCs, throughout the product's life cycle. All right. Well, VOCs are a problem. Usually, it's a big concern for human health because it's like, think of sort of gases that go around and stay in the room and so on, right? But if you make something at scale, that can also cause a lot of issues in the environment. So certain materials are much less likely to emit VOCs. And finally, use materials with a low environmental footprint. Well, that's kind of, could be the conclusion if they want, because that's so wide, right? The next topic is design for manufacture. So when you design the product, you think already of how it's going to be manufactured, right? So they suggest 7 or 8 ways to do that. Number one is reduce energy consumption. Yeah. So just as we mentioned, you pick steel, well, the steel is going to have to be made, okay, but rather than aluminum, which takes much more energy, right? Reduce consumption of natural resources, for example, water. Or for example, if you pick, cotton from a certain area versus another area, in some places, the cultivation methods will consume a lot more water, for example. Okay. Mm-hmm. Next one is reduce process waste. Well, for example, if you pick a manufacturing process that's much more mature, well, maybe 99% of the parts are going to be okay the first time without any rework or scrap. That's much better than an immature process where you have 60% first pass, good parts, and then after rework, maybe you still have to dispose of and maybe recycle or whatever, throw away. Maybe 10-20% of the parts. Terrible, right? Next one is use internally recovered or recycled materials from process waste. Okay, that's sort of my example about cork, but there's so many others. Like for example, if you do plastic injection molding, you don't want to reuse the first parts that are no good or whatever. Well, you regrind them, then what do? Maybe you need some fixtures or another part, maybe for assembly, maybe for painting, maybe for something else, right? So you can still do something with it where it's going to be adequate for the needs. You don't just throw it away. Reduce emissions to air, water, and soil during manufacture. Yeah, that's sort of, like for example, maybe if you're doing painting, then you have like water running and things to suck the air. To really catch all of the paint that goes into the air, whether you spray like powder coating or if it's liquid or something, there's always going to be a lot of air emission. Okay. And then you take that all these substances and you have an abatement facility, maybe on the roof of the factory or somewhere, and you grab it all together and then you dispose of it properly, right? You don't just let the stuff go into the air everywhere, or but I saw some factories where they do the abatement, but then they have all this, this sort of juice, I call it, coming out of it, disgusting. What do you do with it? Like when it overflows like this, where does this lead? Like well, it's like
the stream running around the back of the factory.
Yeah, it's like rainwater, it goes to the river.
I can imagine.
Okay, well, good. You tick the box, guys. With the abatement equipment, you shell out the money, but you don't even do the regular work to make sure it's worth it. Anyway, TIC, right? This is China. Consider reducing the number of parts. Yeah, right. Sometimes it's worth making parts that are a bit more complex, but maybe you don't have to. You don't have to do so much assembly work on them, and maybe they are much more sturdy, and the whole product is more durable. Okay. One example is Tesla has been working on in their body shop, like an enormous kind of press that would put into shape like the whole car body at once. So they don't have to do so much welding like traditional car manufacturing. Well, okay, well, they have an enormous press, but then maybe overall it reduces a lot of the other processes. Okay. And finally, reduce use of hazardous process chemicals, such as volatile solvents. Well, I mean, typical example of that is switching from oil-based paint to water-based paint, right?
Yeah.
So in the 1980s, GM did that first with cars. Actually, my ex-partner, David Collins at CMC, was one of the two engineers. He was leading that team that got to that. So that was like an enormous achievement. And then all the other car manufacturers did that pretty soon after. So that was a very big win. But I still see a lot of manufacturing processes where it's all about oil-based paint, right? In so many applications. Well, yeah, it does. It does force some process changes. It does take longer to dry and so on and so forth. But it is possible to go with water-based paint in a lot of different applications, right? And you remember David Collins. You worked with him also a bit, right?
Yeah, absolutely.
Yeah, he had so much good experience.
Yeah.
So next topic is design for transport and distribution. Okay, so yeah, the product's gonna have to be transported, brought around, right? So we'll come back to some of the same as mentioned before. Reduce product size and weight. Yeah, same thing. Of course, it has an impact for transportation for sure. Optimize the shape and volume for maximum packing density. So, can you think of a retailer that does that pretty well in furniture?
In furniture, IKEA is the obvious one.
Right. All flat packed and high density. So typically their products, the packages come up with lower volume than much less optimized furniture packaging. That's much more typical.
What I would say on this as well, as someone that's recently done my kitchen, that a lot of the kitchen manufacturers also offer the kitchens in flat pack as well, and we're talking like big units. All of the stuff. They can be ready-made as well, but imagine trying to put them all ready-made onto a truck. You need a much larger truck, so they do tend to come in flat pack as well, which I thought really surprised me.
Oh yeah. I was not suspecting that, but this is sort of the trend. Then it can be made in a very big factory somewhere in Poland or somewhere, and then they ship it all around by truck, right?
Right, so, exactly.
Not too surprising. But this sort of pre-built and highly optimized sort of modules, that's the trend a lot in construction in general. Okay, commercial construction in some types of projects only, of course. Okay. Next one is optimized transport/distribution in relation to energy efficiency and emissions. Yeah, so how are you even going to transport it, right? So are you going to send by like a big batch and to a central warehouse in somewhere in maybe Nevada, and then from there send everywhere in the US, or are you going to do whatever? It's a small product, maybe are you going to do drop shipment? Are you going to, drop shipping, hey, it's a lot of smaller packages. You need to have more packing material probably. It might be less efficient in terms of shipment, but of course don't send by air if possible, right? If you can just put it in a standard 20-foot or 40-foot container on a big ship, usually it's going to consume much less energy. Or the train, right? Now, if it's from China to Europe, for example.
Would you also consider the door-to-door transport at this point as well? Because I don't know about the States, for example, but here in the UK, Amazon have recently changed all of its vans to electric vans, I think. No, I think they're trying to change it. And I think some of the other companies that do deliveries use electric vehicles as well now. So would you make the decision to consciously say, we want to use EVs to do the delivery, the last mile?
Well, when you design your product, I'm not sure you can have that much of an impact here. However, when you design your product, you can design it so that maybe for distribution within the country, maybe the size of the packages, is it going to fit in like a FedEx box, or is it going to be like a much bigger FedEx box, So if it's just a little bit too big for the medium size, then you're going to have to go for a large size FedEx box. That's going to take a lot more transportation volume in the trucks, let's say. So that's an example where product and packaging design can come into play, because packaging accessories are just parts of the bill of material, right? They're part of the product, so it definitely has an impact. Next one is reduce the embodied energy in packaging. Yes, some certain kinds of packaging are much more energy intensive. That's for sure. And some other points, but I'm going to come to it, is just the next point. So I'm going to go through it. Next one is use packaging that emit low or zero VOCs. So again, there's certain substances, certain materials you just want to avoid because of VOCs. Okay. Next one is increased use of recycled materials in packaging. So that's the classic one where they say, "Oh, this little part of the cardboard is recycled." You know, well, how much of it really is recycled, or also is recyclable? But that's for the last part of the product life cycle. You know, design for end of life. So we'll get to that later. Finally, the last one in design for transport and distribution is increase the sharing rate, such as ride-share options of commuting cars. Okay, I'm not really sure how you know, this is more like when you design the product and the packaging, but also you design a whole experience, right, of the product you have to offer. So yes, in some cases, the companies really design like a not just a product, but like how to say, the product and the way it's going to be used and the way it's going to be, you know, offered and the way they're going to charge people for it, etc., to encourage a certain type of use, right? So that sometimes makes a lot of sense. Okay.
Yeah.
Then we still have two big topics to go. Next one is design for use, including installation and maintenance. So this obviously is a big one for like electrical appliances, right? Like oven, fridge, this kind of like vacuum cleaner, etc., right? Not such a big topic, for example, for mobile phones or iPads, where all of the energy and materials consumed and everything to make the battery, to make the casing, to make the display, to make all these things are a huge part of the total environmental impact of these products. And then when you use it, you know, whether you use it 1 hour a day or 2 hours a day, well, it's not going to have such a huge impact, okay, on the environment relative to the total impact of that product, of course. But when you buy an air conditioner, that's the opposite tendency, right? Mechanism at play. It doesn't come with a battery or a big display or things like that. Okay, it can be done for relatively cheap. There's only one or two components that really are, you know, relatively pricey. But the more you use it, the more it's gonna have a big impact on the environment. That's for sure. So you also need to modulate, right? Design for materials, design for manufacture, design for use. Depending on the kind of product, some of them are going to be much more important than others. Okay, so design for use. Let's go through them one by one. So reduce energy consumption in use. Okay, so that's the obvious first one, and that's why. So I often come back to the European Commission because they are often the front runners in regulating things, and it kind of shows where some other countries are going to go a little bit later. Well, they've been regulating that for a while, maybe 10 years already, with the ERP directive, energy. Oh, sorry, it was ecodesign for something, I forgot. It was the original ecodesign directive that really very much focused on the energy efficiency of certain types of products, typically the big electrical appliances, right? So, if you buy, I don't know, a boiler for, you know, the water for the shower, you have these types of, you know, A, B, C, D. I guess you see that in the UK also, right? You have an idea about how much environmental impact it's gonna have, right?
Oh, yeah.
How bad it is, right? So that's That's a big one. Number 2 is reduce consumption of natural resources, including water in use. Yeah. So, for example, coming back to the shower, you have these shower heads that supposedly allow people to consume less water, maybe by having, less water flow, but maybe higher pressure.
Yeah.
Okay. Now, I've had industry specialists tell me that actually it's not really true. It doesn't really reach its sort of promise, right? But it's a very nice image. I just have a doubt whether it really, in the end, you really consume less water. Okay, but that's the idea. Next one is optimize quantity and nature of consumables, right? Yeah, like a car, how much engine oil does it need, right? That's an example. Or can it use something that's maybe less impactful to the environment? Okay. Maximize the product lifetime. So there's 4 of them about maximize product lifetime, right? That means, usually we talk about durability, reliability, but here they have a nice way of cutting it down. So you maximize product lifetime in 4 ways here, like 4 major ways. One is designing for durability and reliability. Okay, so durability means it's going to take some stresses. It's less likely to break, like because of a relatively high stress. Reliability is it's going to take some stresses, maybe mild stresses, but like repeatedly, and it can last for longer. Okay, so if you, for example, in when they design planes, right, in Airbus or Boeing, they know that certain metal parts are going to be subject to a lot of stress, like repeated stress, right? Every time it takes off and it lands, and there's certain things that just accumulate, right? And a plane might be in use for 20 years, 25 years maybe. So they want to use materials that don't suffer fatigue, for example, right? So ferrous metals, right, based on iron, tend to have fatigue. So they behave okay until a certain number of cycles, and then very fast, from a certain point, they kind of degrade. Okay, so that's really what you want to avoid. That's just an example. There's many, many ways. And Andrew talked about it at length. Andrew Armenovin, our specialist about reliability, came on the podcast a number of times and talked about that. So yeah, durability, reliability, super important for maximizing the product lifetime. The second way is ease of maintenance. Okay, so I remember we shot a video about designing for like maintenance and so on, and I have like a comparison of 2 photos: a BMW engine versus a Toyota engine. Toyota engine, you can reach what you want pretty easily. BMW engine, it looks like a magnificent beast, like it's wonderful, it's amazing. But how are you going to go and reach exactly what you want, right?
No, they're a nightmare. You can't even get the spark plugs out. You need special spark plug grabbers to actually pull them out. They're like a weird angle and stuff. It's a nightmare.
Yeah. Are you driving a BMW? How do you know that?
No, I used to. And to being the operative word. Yeah.
I see. So
no, my car, I've got a French car now.
Oh, okay. All right. Yeah, ease of maintenance, right? So if it's easier, then you're going to tend to maintain your device, your product better, right? Whereas if it's really hard, well, good luck. Like air conditioners, you just pull the filter, you clean it up a bit, and you put it back. It's relatively easy, right? That's a good example. Not the most pleasant experience, maybe, but not so easy to make it better. Number 3, designing for repairability. Right. So, yeah, you talked about Apple before, and that's one of the areas where they really fell in hot water. Actually, so looking at the iPhone 13, if you had to repair it, first you have to go to a special shop, etc., etc. Otherwise, anyway, they make it very difficult.
Yeah, there's no way you can just do it at home.
And then you have to to reach out certain parts is really, really terrible. And you have, the certain parts that are glued, like how you're going to undo that and without breaking everything, and how you're going to reach something at the back if you open it from the front, that's sort of issue. In the iPhone 14, it doesn't look like a big change, but internally, the 14, not the Pro or Pro Max, but just the 14, actually inside is built in a totally different way. And you can access the different, the two sides, front and the back, much easier, right? So they have been working on it. They have been feeling the pressure, so it's good. Keep the pressure on. But repairability also means, access to spare parts long into the future. No obligation to use a special kind of screwdriver or something, special tools, having access to maybe the schematics of the products and so on to actually understand how to do the repairs, right? All these kind of things come into play. So there's a lot to it. And then number 4, to maximize product lifetime, is designing for refurbishment / remanufacturing. Okay, so an example is the tires. It's amazing that some tires, they sent back to the factory and they just sort of add up rubber onto it if you want, right? That's amazing. Also, one of the French car brands, Renaud, in one of their older factories, they are starting to get some of their old cars, and they refurbish them, right? And then they resell them. They try to really encourage a circular economy, and that's pretty cool. And a lot of electronic brands do refurbishment, even Apple, right? You can buy refurbished iPad and things like that. So that's really a good.
Definitely.
That's really good because, as I mentioned, most of the environmental impact of an iPad is making it. So some people are going to drop it after, 2 years because there's a brand new super cool iPad Pro whatever that came out, and it's such a shame. But then if you can have somebody else use it for maybe another 4 years, that's an enormous win for the environment, right? Okay, so and then there's two more points here about design for use. Reduce emissions to air, water, and soil, right? So on the one side, you have reduced energy consumption and consumption of all the resources, and on the other hand is the emissions to air, water, and soil, right? So, yeah, Mr. Musk would say, "Oh, look at our Tesla, zero emission." To which we say, well, zero direct emission, right? I mean, when you sell a Tesla in China or in the US, what proportion of that energy is made by burning coal or gas? Right? So anyway, there's a whole debate about that on a number of products. But yeah, in some cases it's pretty clear. And yeah, an example. And here again, it comes from a regulation in the EU, the washing machines for clothes, right? So there's a big problem in the environment these days is that there's more and more microplastic. And whenever we buy, that cool polyester, sport, whatever, t-shirt or short pants or something, and we wash it and we wash it and we wash it, well, actually there's small parts of the polyester or the nylon or whatever it is that just go with the water, right? And pollute the river systems and end up in the ocean or in the soils and so on and so forth, right? In the fish that we're going to eat, etc. Okay, so they're gonna force washing machines to have some kind of filter to recuperate that all these microplastics. So that's an example. And by the way, there's a product also. I saw it on Kickstarter. There's a company called Matter, Matter, in the UK that's actually developing this kind of filter, right, to equip relatively older washing machines. Okay, and then finally, minimize or eliminate hazardous substances during use. So yeah, of course, if you can avoid, internal combustion car engines, I always come back to this kind of example. But there's a bunch of gas inside, the gasoline in the tank, that's a little bit hazardous. And in some cases, it might make an accident much worse and cause actually a lot of environmental damage also, right? When we move to batteries, I don't know if we are really trading for something better here, but anyway. But at one point in the 80s and early 90s, there were these cars with liquid gas. I don't know if you remember. And that also was rather hazardous.
You mean LPG?
Yeah, right.
I think before Shenzhen went fully electric, I remember they'd converted the buses to be maybe LPG buses and the taxis, the ICE taxis, not the EVs. Of course, if you go to Shenzhen these days, as you recently have, everything's like electric now, basically. But
battery.
Yeah, I think people with larger like 4x4s and cars like that in the UK converted them to LPG. But yeah, it seems to have been something which came and went in popularity quite quickly.
Right. Yeah. So the use of hazardous substances. If it starts a fire or something, that can be really, really bad for the environment. Not to mention personal safety, right, or property safety. Okay, and then so the last design focus area, as they say, is the last step of the product life cycle, design for end of life, right? So there's 6 points here. I'm going to go through them quickly. Number one is restrict use of substances classified as hazardous. Yeah, because when you have hazardous waste, what are you going to have to do with it? Maybe you're going to have to bring it to landfill, to have it incinerated. You're going to have maybe to have a specialized company, licensed company come and collect it, right? Whereas if it's not hazardous, it actually invites the thought, hey, maybe we can do something with it, like a second life in another way, or maybe reprocess it to recycle it, right? But if there's something hazardous, it's going to be like put aside and maybe burned or something like that, right? Number two is maximize the ability to reuse and recycle components and materials, for example, designed for disassembly. Yes. So if you make it easy for the products to be disassembled, for example, by the Daisy robot that you mentioned, it's much more likely that they're going to be disassembled. But if everything is very, very small and is glued together or is like all molded together like an AirPod, well, forget it. The AirPods are not going to get recycled, right?
Yeah.
There's just no way. It's terrible. Number three is minimize design aspects detrimental to use and recycling. For example, mixtures of materials. Yeah, when you make certain alloys or you combine certain things together, maybe you print on something. Okay, you use certain colors, for example. All of a sudden, well, it's no longer recyclable, because if we want to recycle and sort of separate it properly, it's no longer economically feasible, right? That's a big one, actually. Packaging is very, very guilty of that, but not just packaging.
Christmas cards, they're a good example.
Right.
Okay. With all the sort of like the gold coloring on them and things like that. You can't recycle those.
Sequins and things. Yeah. When you have packaging that just mixes too many things together, forget it. It's not going to be recycled. Number 4 here is reduce amount of residual waste generated. Yeah. So, you have less waste to deal with. It's less material that is, that has to be taken care of. Okay. Number 5 is reduce energy required for disassembly and recycling. Yeah. So if it's easy to disassemble, if it's relatively easy to recycle without doing an enormous amount of work, reprocessing. So, for example, paper. Well, paper itself can be recycled easily, but if there's a lot of ink in it, the process of recycling it is much more energy intensive. That's an example.
Yeah.
And finally, reduce water required for disassembly and recycling. Yeah, in some certain types of products, you need to use a lot of water. And then what do you do with the water? Usually it's it's pretty dirty. Are you really going to retreat the water? Well, that again requires more energy and like specialized equipment and so on and so forth, right? So, yeah, we went through the whole product life cycle.
I don't even know how many points there were. I guess I could have counted them before we started this, but that's got to be sort of like 40 points or something like that. Now, if you're listening and you're thinking, wow, that's a lot to think about. For example, if you're going to be importing products into the EU, actually you're going to need to think about and to be able to calculate this sort of information, aren't you? So it's not like a nice to know. This is a must, certainly coming soon, at least.
Right, absolutely. Obviously, you don't have to do everything. Sometimes for certain types of products, you really focus, you optimize your design for one of these points, and you already have a massive win. You might, however, you calculate the impact. If it's, usually it's better to calculate the impact of a product on more than one metric. Don't just look at the amount of like equivalent of carbon emitted or anything like that, right? But amount of energy consumed or something like that. Okay. Sometimes you really optimize for one of these points, and you have a massive win. Maybe you reduce by 20%, 30%, and some others are going to be much less bang for your buck, basically. So you might really want to start first by looking at, okay, what's the biggest source of the environmental impact, right? And how can we, if we did that instead of that, what would have make the biggest difference, basically.
And you'll do that doing the life cycle assessment?
So when you do a life cycle assessment, you collect all the data you can. And yes, when you have a life cycle assessment, the data that go into the assessment, really looking at it, you can have an idea, right? Oh, okay, that these are like big sources of environmental impact, right? If we change this and this, what's the sensitivity, right? A life cycle assessment can help, yeah. The problem is that life cycle assessments come in all kinds of flavors with different assumptions. You can have very different results, but it's very useful as a way to plan, to look at the numbers and play with them a bit. Okay, if the assumptions are not too crazy, and the whole set of data is not worthless, of course, right? Well, you can, even if it's not exactly accurate, you can already pinpoint, whatever. Maybe it's, if it's an air conditioner, as I mentioned, it's pretty obvious that's during use, right? So how are you going to make it more energy efficient, or how are you going to maybe direct the flow of the cold air in a better way so that people don't feel so hot? Or how are you really going to reduce the energy used when it's in use, right? That's a very obvious example. You really need to focus on that, I would say, first and foremost, right? Then when you really optimized it to death on that aspect of it, you start to look at other points.
And I suppose bearing in mind today's topic, which is designing a product to have a lower environmental impact. If you're going through this process and you've got existing products, I guess it's much more difficult to make positive changes to an existing product that's currently being manufactured and is on the market. But what you'll be doing, when you're going through the life cycle assessment process, and basically you're focusing on how to reduce environmental impacts, you're going to take these learnings into your next product. I suppose that's more likely, isn't it?
Exactly. Yes. Your version 2 or version 3 or whatever. If you feel that it would give you a competitive advantage, and in many cases it also cuts your costs, right? Or it allows you to actually charge a premium because you can show, look, it's more durable, it consumes less energy, blah blah blah, and then here's the total cost of ownership to you, Mr. Consumer, right? In some cases, you can really charge a premium and develop a certain reputation for your products. It's a way of differentiating you in the marketplace. But in some cases, it's just a smart business to cut your costs, right? There's a lot of that too.
Yeah, Makes sense. I mean, in Europe, for sure, marketing based on energy efficiency these days it's shot up in popularity. It's everywhere. Everything's got to be, it's the most efficient. You've got to have an air fryer now. Forget normal ovens. It's all about air fryers and whatever, and that was never around, sort of pre-COVID, really. Not to the extent that it is now. So, I mean, this kind of approach, it's a real thing.
Yeah. I think it's really here to stay. And, hopefully we pointed our listeners to, a methodology that can help. And
absolutely.
And also I'm going to repeat, is the IEC standard number 62430, published in 2019.
Yeah, the link will be in the show notes, and to some of our accompanying content as is usual. So yeah, that's a good one, Renaud. Energy efficiency, environmental impact, all of these things, so important these days. Good to cover it. And yeah, I hope everybody listening has found a lot of value in that.
All right. Thanks.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.